So in this video we're going to do the inverse Laplace transform of this function here, 2 plus s minus 3 times 3s plus 4 over s minus 1 times s plus 2 squared. Now this is a complicated looking fraction, but I reckon the top will form a quadratic. In the bottom we've got a cubic. So that's good. We've got a function here where as s approaches infinity, our function here approaches 0. So that is good. So first of all, let's break down our f of s into p of s over q of s. Now let's deal with this numerator. So p of s equals 2 plus s minus 3, 3s plus 4. Okay, let's expand this out and find our quadratic term. So we've got 2 plus 3s squared minus 9s plus 4s and minus 12. So we can simplify this off a little bit now and we'll get 3s squared minus 9 plus 4 is minus 5s minus 12 plus 2, that's minus 10. Now that's our numerator. I'm not sure how we can factor that out, so I'm going to leave that as it is for the moment. Now our denominator, s minus 1 over s plus 2 squared, let's just write that as our q of s. Now this looks like we're setting ourselves up for a partial fraction decomposition. So therefore f of s equals 3s squared minus 5s minus 10 over s minus 1 s plus 2 squared. Okay, now from this point in this video I'm going to go straight to the result of the partial fraction decomposition, just so as we can concentrate on the question in hand. But this here, we found the result of this in the previous video, which you can see in the link below, and what we got was we got f of s equals minus 4 over 3s minus 1 plus 13 over 3s plus 2 and minus 4 over s plus 2 squared. So that's what we got for our partial fraction decomposition. Okay, so let's continue with this up the top here now, and let's try and find our inverse Laplace transform. So we've got our function up on the top now. So now we're ready now to go into finding our inverse Laplace transform. So what we're looking for is the inverse Laplace of f, which equals the inverse of minus 4 over 3 s minus 1 plus 13 over 3 s plus 2 minus 4 over s plus 2 squared. Okay, so now I'm going to break these apart into three separate inverse transforms. So now I'm going to have the inverse Laplace. Now this one here, I can take the constant out of it as well. So I've got minus 4 over 3. So let's write that over here like this. So minus 4 over 3. And then I'm left with 1 over s minus 1. Now this one here, I'm going to do the same. I'm going to take the constant out of that one as well. So now I'm going to add the inverse Laplace, 13 over 3, 1 over s plus 2. So that will take care of that with positive sign. And now here, subtract. Now I'm going to have 4 times the inverse Laplace of 1 over s plus 2 squared. Okay, now these two here, our general result for these are c times the inverse Laplace of 1 over s minus a equals c e to the a t. So these are in that kind of format. So looking at these, for this one here, c equals minus 4 over 3 and a will equal, well here it's just minus 1, so a equals 1. This one, c would equal 13 over 3 and a would equal, here we've got minus 2. This one is a different story. We're going to come to that one in a moment. Okay, so let's put our result using our general result here. So now we've got minus 4 over 3 e to the t. That takes care of that one. Now this one, plugging into here, we've got plus 13 over 3 e to the minus 2t. Okay, now what about this one? Now this one uses similar parts to this, but we need to also deal with this squared term. So I'm going to write this one on here in place of that one to show you what we do. So now we have the inverse Laplace of 1 over s minus a squared, and then we can multiply that by a constant as well here again. This now becomes c times the inverse Laplace of 1 over s minus a. So that is as before, and again these are all multiplied, and then we'll multiply this by another one, which is the inverse Laplace of 1 over s to the n. So here our s would just be this term here, so that will be s squared, so s to the n, so n will be 2, and then the result of this would give us c times e to the at. So that is as it was for these results. And then this one, we multiply that by 1 over n minus 1 factorial, and then t to the n minus 1. So that's our general result when we have this format here. So looking at this one, our c is minus 4, a equals minus 2, same for this one. But now we've got an n here. So n equals 2. So n equals 2. So now our general result will be c, so that's minus 4, e to the at, so that's minus 2t, and then 1 over n minus 1 factorial, so that's 1 over 1 factorial, which is just 1, so we can just leave that constant as it is. And then we need t to the n minus 1, so now we're just left with a t. Okay. So that there is a valid result, but I'm just going to neaten it up a little bit. So I'll put my constant term with a positive at the front. So 13 over 3e to the 2t. So I've got a positive term for the 2t. And then minus 4e to the t over 3. That takes care of that one. And then here, minus 4t over e to the 2t. So that's again minus 4t, e to the 2t in the denominator. So that is the inverse Laplace transform of my function f. Okay.